An equation has an equal sign. The solution to an equation makes both sides equal each other so that they are true. A linear equation with one variable is anything with some numbers, one variable, so one letter, and then some numbers on the other side. To solve using the distributive property, first we'll multiply the 5 by the y and then the 7. So we'll have 5y minus 35 equals 25. There's our equal sign. So next we'll get rid of the minus 35 by adding it to both sides. It'll cancel out, and we have 5y equals 60. To undo 5 times y, we divide both sides by 5, and we come out with y equals 12. To do 1b, we'll start out the same way. 2 times 5 is 10. 2 times x is 2x. That equals 30. There's the equal sign. To get rid of the 10, we have to recognize that it's a positive 10. And in order to get rid of it, we will need to minus 10 from both sides. We're left with negative 2x. See how we still have that negative sign out front that we recopied? So negative 2x equals 20, because 30 minus 10 is 20. And the last step to undo that multiplication, we divide by negative 2, and we get x equals negative 10. To solve equations with variables, the letters on both sides, we'll make the line down the middle, and then we look at each side. We notice on the left, we have those terms that we can combine. So we have 6y plus 28 equals, and on this side, we have the 4y's and the 5y's we can combine. All together, that's 9y minus 20. Now I just need to put all the variables on the same side. So these are positive 6y's. I'll do the opposite to take them to the other side and subtract them. And we'll subtract 6 there. So that will leave us with 3y's. We copy the rest. Minus 20. Now we need to get rid of the minus 20 over here, because remember the goal is to get that y all by itself. To get rid of the minus 20, we'll add 20 on both sides, which means that side equals 48 equals 3y. And to undo the multiplication between the 3 and the y, we'll divide both sides by 3, and we get y equals 16. Let's try solving 3a. We have the equal sign. On the left side, we'll combine the 3x's and the 4x's to get 7x plus 5. On the other side, we have 7x plus 5. Now, you might stop right there and think, if we have the same thing on both sides, whatever we plug in right here, we'll plug the same thing in right here, and those sides will always equal each other. If you didn't notice that, you might continue to try to solve by minusing 7x and minusing 7x, and then you might realize that the variables went away, and that's sort of weird, but when you write your leftovers, you have 5 equals 5. And that is a true statement. 5 does equal 5. So when you get something that's true, you say the answer is all reals, or you can write that R symbol. It stands for all real numbers, because any number will work if you plug it in for x, because it's the same thing on both sides. When we try the next one, we'll start by distributing. So we have 8y plus 56 equals, now on this side we need to combine the 6y's and the 2y's. So we have 8y minus 8. So let's get the y's on the same side. We'll minus these 8 and put a minus 8y on that side. And oh no, you notice they cancel out. Well, when we write the leftovers, 56 equals -8, that does not make any sense. That is a false statement. When you get something that's false, when the two sides don't equal each other, instead of all real numbers working, no real numbers work. So we say no solution, or you can put that symbol right there for your answer. On example 4, you treat the inequalities, the things with these less than or greater than signs, the exact same way you would treat an equal sign. We have the two sides. Our goal is to get all of the variables on one side. I'm going to move those positive 9x's over to this side by subtracting them. So they cancel out there. 12x's take away 9x's is 3x's. I'll recopy the positive 4. I'll recopy the less than sign. And this is I think that was a -11 to begin with. So -11. Next, we continue to solve for x by getting rid of the 11. I'll do that by adding and adding. So we have 15 is less than 3x. The next step would be to divide by 3 on both sides, and we get 5 is less than x. So we go to the number line, we put the number 5 on, here's 0, 1, 2, 3, 4, 5. Since that's just plain less than, no equal sign underneath, we put an open circle, and the big side of the sign is pointing to the x. That means that the shading has to go on the side that's bigger than 5. So you would shade to the right. If you rewrote this inequality, you could do that. If you want to flip-flop the x and the 5, that's fine. But then you flip the direction of the sign. Instead of going that way, you would write it that way. If this is easier for you to read with the x first, then you could look at it and say that x is all the numbers on that side, the right side of 5. We will solve the next one a similar way. We have the middle. We need to get the x's all on the same side, so I'm going to move this positive 1x over to the other side by minusing 1x, which will leave us with 3x. I'll recopy the 8, recopy that sign, recopy the plus 1.7. Now, to solve it for x, we keep going. I'll get rid of the positive 1.7 by subtracting it. Subtract it there. And we get 6.3, our inequality sign, and 3x. Last step is to divide both sides by 3. And we have 2.1 is greater than or equal to x. So like I said before, you go to your number line. If 0 is right there, there's 1, there's 2, so we'll go a little bit past 2 to about 2.1. I'm putting a closed circle because this has the equal sign underneath it. And this time, the little side of the sign is pointing to the x. So we need to shade to the left. If you prefer to flip-flop the x and the 2.1, so the x is first, you're welcome to do that, but then you also flip the direction of that sign. If you prefer to read it this way, same thing. X is less than or equal to 2.1, and so you shade to the left.